So we present the migration mode, and Leandro is going to talk about how to attack these APs.
Okay. Hi, can everybody hear me? Okay, great. Okay, kicking off where Diego left off, I'm going to start talking about how to attack an IP configured in this manner. So basically, the first step is that when we bumped into this at a customer of ours, and something smelled fishy of having this hybrid configuration, so we started to see what we could do with it. So the first thing we did is we started looking and browsing through the documentation to see what we could find that Cisco was saying about this WPA migration mode. So basically what we found is that Cisco says that the security will operate at the least secure level common to all devices. So this basically split the scenarios into two possibilities: when you have web stations and when you don't have web stations, which are going to be the two cases that we're going to try to attack the AP under these two different scenarios, because they say that basically it's secure as the least secure common to all devices. So, okay, if we don't have web devices, this should be as secure as WPA. And we found that it doesn't matter if they're web devices or not, this is only as secure as web. So it's completely unnecessary. And another thing that we found is that Cisco only acknowledged the possibility of doing a passive web key attack. What we're going to show is that you can do another types of attack, which are much more interesting. Basically, the first scenario, which is a trivial case, the easy case, is when there's still web stations hanging around. So in this case, what we have to do in order to crack the web key is we can do a standard attack that AirCrack implements. And what we do in this case is instead of attacking the AP, we attack a web station. As there are web stations using the network, we can just target one of those stations. And in this manner, we forget about how the AP is configured. It doesn't really matter for us because as we're attacking a station, the attack is completely oblivious of how the AP is configured. So basically what we do is we passively wait and sniff to find a broadcast ARP frame, which we can distinguish even though it's encrypted by its characteristic size. And as Diego mentioned, all broadcast traffic is encrypted with WEP, which is what all stations would understand. So basically what we do is we wait to see that type of frame, and we wait to see a frame that is answered by a web station. And we can see this by doing a little bit of traffic analysis and seeing when the station replies. So what we do is we capture that frame, and since WEP has no replay protection, we re-inject the same frame, sending it directly to the station. That's why we have to set the from DS bit, which means that the packet was coming from the AP. So the station would see the packet and say, okay, somebody's sending me a frame, it would decrypt it, and since it's a valid frame, it would be an ARP frame that we captured. The station's gonna reply, and each time the station replies, we capture that traffic, and that traffic will be valid web traffic sent by the station. So if we capture only that traffic and we gather enough of that traffic, we can crack the web key under this scenario. This is a standard tool. AirReplay performs this attack in its standard configuration. Basically, the attack is using the -2 option of AirCrack. And below is the documentation on how to carry this out. So this basically is the trivial case. Now, we're going to go into the more interesting case when we assume that there are no longer any web stations connecting to the AP. So we only have WPA stations. And this was a scenario that we found at our customers because they had finished their migration, but they never turned off this feature. Everybody forgot about it, and they just left it on. Since they thought that they had all TKIP stations, they thought they were secure. So what we found is that we can still crack the web key. It takes just a little bit more, just a few more steps, but it's fairly easy. What we do is we first authenticate with the access point as a web station. This is very easy to do. We can use AirCrack for this first step. And since we authenticate as a web station, we don't have to prove knowledge of the key, as the web is configured in open authentication, and this is a requirement by Cisco in order for it to work in this mode. So we don't have to prove knowledge of the key. Then we wait and capture a broadcast ARP frame, which will be web encrypted as it's a broadcast frame. We bit flip it using what Diego described earlier about message tampering. And we do this in an intelligent way so that the ARP frame becomes an ARP frame from our station, because we know who sent the ARP frame, and we know our MAC address, and we know the source MAC address of the sender. So we can calculate a mask that, even though we don't know the specific contents of the frame, we can build a mask that if we apply it to the frame, we can obtain a new frame, which is also web encrypted and valid, but that is an ARP frame that, as if we had sent it from our MAC address. So what will happen is that when we send this frame, we send it to the AP, and since we have authenticated as a web station, the AP does not have any trouble in getting that frame and forwarding it along, because we are a web station, so we are allowed to send web traffic. So basically, the AP sends it along. This frame that the AP sends is re-encrypted, is also encrypted with web, so we can use this frame for cryptanalysis purposes. So we have to be sure and capture these frames. And also, the station for which the original ARP was sent will reply. And once the station replies, the reply will be sent back to us by the AP, and it will be sent as a web frame since we are a web station. So therefore, we have for each frame we sent, we have 2 frames that are web encrypted and that can be used for cryptanalytic purposes. So then what we do is we run aircrack against it to obtain the web key. Basically, at the full URL below is our site for research, for Core Labs research, and you're going to see what we're going to demo. We made some patches to aircrack so that we can carry out this attack using aircrack. So basically, I'm going to go over this with a diagram because I'm pretty sure nobody understood before. So I'm trying to, this is the main focus of the talk, so I'm going to go over it again so that when we see the demo, everybody can follow it. Basically, the scenario is this one. We have 2 WPA stations, and we are the attacker. Then the station A sends a ARP frame, which is TKIP encrypted, because it's every time that a WPA station talks to the AP, even if it's sending broadcast traffic, it encrypts it with TKIP or IS if it's using WPA2. Because in WPA and WPA2, since everything has to go through the AP, stations never use the broadcast key to encrypt. They only use the unicast key to encrypt, and then the AP uses the broadcast key if it has to forward it along. So basically, this is sent in the air as a unicast frame, which the AP then re-encrypts as a web frame because the multicast cipher is web, and it's sent on the air. So this frame we can capture because it's a web frame that we need. Then the station B will see that frame, the ARP frame, and will say, okay, now I have to answer that. It will send a unicast reply encrypted with TKIP. This reply will be forwarded by the AP onto station A, and also TKIP encrypted using the key that the AP and station A share. And what we do as attackers is the frame that we had captured, we flip it to turn it into the same who has request for station B, but this time coming from our source MAC address. And then what will happen is that the AP will forward it. That frame is a new web encrypted frame, which we can use for cryptanalysis. And then station B will reply also in TKIP because it's a WPA station. But the AP will forward it to web to us because we are a web station and we have authenticated as a web station. So the AP tracks the encryption everybody's using, and he sends it along in the proper manner to us. So that's another frame we can use for cryptanalysis. So here, what I'm going to talk a little bit is that a similar attack to this one can be carried out without having to patch aircrack, but it has a few caveats that must be taken care of. The first few steps are the same, but what we do is, instead of flipping the frame, we just re-inject the same frame. And the problem that this has is that we're only going to have 1 frame sent per frame that we send because it's going to be what the AP forwards. And the other problem is that aircrack either expects the network to be WPA or expects the network to be web. So when we run the cryptanalytic process on it, if it detects the network as web and there are TKIP packets in the capture, what it will do is it will throw off the cryptanalysis because aircrack assumes that the whole network is web, because when the guys from Aircrack programmed this, they didn't think that there was going to be the case where you had a mixture of TKIP and web traffic using in the same AP. So basically, this can be done with Aircrack, but you have to do it with interactive mode and looking at what you're doing. So basically, what we did is we automatized this, and what we also did was patch Aircrack so that when it detected that it could filter out web traffic and TKIP traffic so that the cryptanalysis was not thrown off and that you don't have to filter the capture before running it in Aircrack. So here, I'm going to show a little demo. We have a video of what we did. So basically, the first step is I'm starting Wireshark in sniffer mode. And here I'm going to implement a filter which basically captures beacon frames from our AP so that we don't have a lot of trash going around in the air. Basically, here I'm going to show that we have a beacon frame, and I'm going to show what Diego was talking about, how to detect it. We see that the SSID is migrate, which is what we set it to be, and that we are using that in the WPA information element, we have a cipher suite of web for the multicast cipher and a unicast cipher suite of TKIP for unicast traffic, and that we're using pre-shared key mode. We could be using 802.1x, just what is easier to set it up in this way. So now what we do is we show the same thing in our patched version of Kismet. As you can see, well, probably you can't because black background screws everything up, but it's marked in red, and it's detected as a WPA migration mode AP, which you can show here. And basically, we added this capability to Aircrack to Kismet, so that when somebody bumps into this, they say, okay, it's red, it's vulnerable, it's the same thing as a web AP. Now what we do is we are going to filter the traffic based on a particular station that has joined the network as a TKIP station, a WPA station. And if we see the frames that it sends, if we look at the data frames that it's sending, what we're going to see is that these frames that have the frame control is 41, which means that the frame was sent from the station to the AP. These are encrypted. That's our BSSID, the source MAC address of that station. And as you can see, it's encrypted using TKIP because that's a TKIP station. And this frame was forwarded by the AP, and it was also forwarded using TKIP because it was talking to another station that was also a WPA station. So here you see all WPA traffic until we go and we set another filter that we look for web frames. We do this by looking for frames that have an IV, a web IV, and in this way we'll filter everything for web frames. And if we look at these web frames, what we're going to see is that the destinations are always either multicast destinations or broadcast destinations, and that the interesting thing is that all the frames are sent from the AP. As you can see, they have the from the S bit set. So that means that they're frames that are forwarded by the AP. And since they were broadcast frames, they're web encrypted. And in this scenario, we didn't have a web station running. It was just the AP and these two WPA stations. So now we're going to go on with what we're going to do is we're going to set the encryption key. Wireshark has the possibility of decrypting wireless traffic